Hello everyone, thanks for coming here. My name is Animesh Singh. I am an architect for IBM Bluemix. And today I'm going to talk about how can you build your own event-driven serverless platform on top of OpenStack. Before I go down that route, I just want to quickly know how many people here know what serverless means. So, for the rest, 60%, around 40%, I think they're aware of the term. Very quickly, I will introduce. If you see the evolution of cloud computing, started with from bare metal, we moved to infrastructure as a service where OpenStack is. Then we have platform as a service offerings like Cloud Foundry, etc. And then container orchestrators like Kubernetes, Docker Swarm, etc. came in. The problem even with something like platform as a service is that it's expensive to scale these microservices. First, you need to take a monolithic application, break it down into different microservices, then make sure that every microservice is highly available, and then make sure that you have it in different regions for the regional outages. The other problem with the microservices current pass-based model is that a continuous polling is needed in the absence of an event-driven programming model. You are charged for resources even when your app is not doing anything. So then, to solve some of these problems, enter serverless. Now, where does serverless fit? You can actually run it on your pass, on top of a container orchestrator, or even on an infrastructure as a service platform like OpenStack. So that I want to introduce OpenWhisk, which is a fabric and platform for serverless event-driven programming model. It's open source on GitHub. It actually allows you to execute application logic in response to events. Now, those events can actually be triggered by external actions, or they could explicitly be invoked using HTTP calls, either through the CLI or through the APIs which are provided. Based on those events, certain actions are executed, and the actions can be written in different languages. So how does it work? For example, when a data event occurs, there is a commit on a Git repository, or there is a CRUD operation on a database. Any of these events will actually trigger, and based on that trigger, there are certain actions which will be executed. Now, it can also be an explicit HTTP-based invocation. For example, if you reach out to a URL using HTTP, it can just invoke that action on the fly on that particular point of time, and then once your job is done, your code is actually then killed again. With respect to the programming model of OpenWhisk, the three things are what we call a TAR. And to describe them, the first thing is trigger, which is essentially a class of events that can happen. As you can see, that events can come from a mobile-based device, they can come from a CRUD operation on a database, from a Git repository, even from your DevOps systems, if a build completes, etc. Internet of Things, that's a great use case for something like this, where you have multiple devices, but you don't want to put up a backend infrastructure which is listening all the time. Only the code gets executed when there is an event which is happening to one of your devices. Actions, which is essentially an event handler, code that runs in response to an event. Now, actions can be written in different languages in OpenWhisk. You can write an action in JavaScript, or you can write an action in Swift, which is becoming one of the more popular languages around. Or you can write it in any other language by packaging it with Docker containers. OpenWhisk supports putting up your own Docker container in which your action is encapsulated. And you can actually create a sequence of actions. You can chain these actions together so that based on one trigger, you are executing multiple actions which are going on in sequence. And then R stands for rules, which essentially defines what actions get executed based on what triggers. With that, very briefly, I will go towards the backend architecture. This slide shows the backend architecture of OpenWhisk. You essentially have different components like router, controller, Kafka, couch, Consul. And to better describe them, I'll use the next slide. So what happens when a request comes in OpenWhisk, Nginx, or the proxy is the first one to intercept it. Once the proxy gets the request, it actually forwards it to the OpenWhisk controller. OpenWhisk controller then goes to CouchDB in terms of figuring out, is the user which is trying to invoke an action, is he authorized And if he is authorized, what are the parameters he's passing, and what are the default parameters do we need to pass back to invoke the action. So once the controller gets that information from CouchDB, it then reaches out to Consul. Now, Consul acts as a service discovery tool in our case. So its main job is to actually discover all the different invoker machines on which the actions will be executed. Which one of them are available, queue them up appropriately. So once controller knows from Consul that these are the set of invocation machines or a particular invocation machine where I can actually push my action, then it puts that request in the Kafka queue, and Kafka then actually passes that there are all these different invokers which are listening to the Kafka queue, and based on that, they are invoked. So your request can actually land on one of the invokers which you have deployed for OpenWhisk. Under the covers, all your actions are getting executed inside Docker containers. With that, let me talk briefly about how can we put OpenWhisk on OpenStack. So essentially, we begin with what we call a bootstrapper machine. And that bootstrapper machine can be on your laptop, or typically, in a lot of cases, you actually can put it on OpenStack itself. A lot of deployments we are doing, we are actually putting it on OpenStack itself. There is a GitHub repository from where you pull down a lot of Ansible recipes in terms of deploying OpenStack, or deploying OpenWhisk on top of OpenStack. It has been tested on OpenStack Kilo and Mitaka releases. At the minimum, we expect the following 6 services: identity, compute, image, network, etc. The typical sizing which we recommend is around 4 CPUs, 8 gig of RAM, and 60 gig of disk for each particular component VM. You can expect to have around 36 vCPUs, 64 gig of RAM, and 480 gig of local disk if you want multiple concurrent event invocations. For network, we essentially create a tenant private virtual network, Neutron, on which OpenWhisk component goes. It goes with its own tenant router. You can have other workloads which are running in other tenants. This should not be impacted. The Nginx or the proxy VM is the one which needs an IP from your external accessible network. So you use the floating IP network for that particular purpose. So to summarize, to kick off things, spin up a VM which we call Bootstrapper, and it's essentially using Gradle and Ansible under the covers to do the build. Then you bootstrap using the instructions which are listed on our GitHub repository. Once Bootstrapper is ready, jump to the following link, and then you can deploy OpenWhisk on top of OpenStack. In addition to the default Ansible modules, we actually created a lot of Ansible modules which make sure that OpenWhisk deployment on OpenStack can be done in a successful manner. There are some parameters which you need to create so that it detects that we are deploying Whisk on top of OpenStack. So the environment variables where essentially you tell Ansible that you are running an OpenStack, what is the URL, credentials, the image which we are using for OpenWhisk deployment, all that you provide. If you want persistent disk for database like CouchDB, you can actually export that parameter. If you don't export it, it won't be provisioning the CouchDB on a persistent disk. It will be on the ephemeral disk of the VM. Now, once OpenWhisk is deployed, you can actually interact with it either using a CLI or using one of the Node-RED GUI editors. Node-RED is also an open source platform which you can deploy, and it actually allows you to create these different invocations. And as you can see, the next generation of applications which are going to come, they are going to be these multi-cloud serverless applications where you are just stitching together different functions which are running on different cloud providers. In our case, we are able to run Whisk on OpenStack. We have a public OpenWhisk which is running on IBM Bluemix. And then we were also able to run Whisk on AWS. And we created an application which is for different scenarios reaching out to the different cloud providers in terms of executing their functions. Thanks. So that's what I wanted to cover as part of this. Thanks.